Hello, welcome to Bloom. In this video, we are going to discuss about micro operations, how it is executed in a program. Now let's see how a simple assembly language program is executed. Here, the current instruction register points to this memory location 0, 1, 4 zeros. The content inside that memory location is 64, 100,000. If the IR register points to this memory location, the program counter, which contains the next address of the program, points to this memory location. What is meant by 64, 100,000? Well, 64 is the opcode and the operand is 100,000 or 150. It says load A from this memory location. So what is the 150 memory location? It is this, right? The control signals will be released to fetch this number, the value from this memory location. Load A 100,000. When it is executed, the program counter is incremented by 1 and the current register will have this memory location. So it will fetch the content inside this memory location. It says 66, 100,001. So this micro instruction means add A from this memory location. Next, it will fetch the value inside 100,001 memory location, which is 2. Then the next instruction is 67, 100,000. It means store A from this memory location. So what will happen? It will store the value added 7 in this memory location. After that, the fourth instruction is 80 and it specifies another memory location. It says jump to this memory location. Where is this memory location? It's the same as this. The program will jump back to this memory location and it will execute again and again. So this is a simple assembly language program and how it is executed. So here the first micro instruction is a series of micro operations. Let's see how these micro operations are executed. This is a diagram of CPU. The main components of a CPU are control unit, ALU and the registers. There are internal data buses and internal address buses which connects these components together, and there are external buses which connect with the main memory. And additional to that, the control unit will send the control signals to execute the related micro operations. So let's see how a program is executed within this CPU. In the previous example, the first instruction was in this memory location 100000, 4 zeros. The instruction was inside this memory location was 64, 100,000, which says load A from the memory location 100,000. So let's see how it is executed. Initially, the program counter has the next address of the memory location of the next instruction to be executed. So it will have 1040 zeros. Now it will send this message to MAR, memory address register, via the internal address buses to fetch the instruction. So it will connect with the external address bus. In the memory, it will get the instruction inside the memory location. So it is load A 100,000. It will come to the MBR register, memory buffer register, and then via the internal data buses, the instruction will come to the current instruction register. Now the instruction register has the current instruction, which is load A 100,000. So this is the fetch cycle. Still the micro instruction is not executed. What happened in this cycle was to fetch the instruction. What happened? PC will connect with bus A connect to MAR will connect with the external address bus and set memory to read and fetch the instruction via the external data bus to MBR, and then MBR will send it to bus D, which is the internal data bus, and internal data bus D will give it to PIR. And what happened then? PC is getting incremented by 1 because program counter always points to the next instruction that needs to be executed. So let's see how this loaded instruction is getting executed. Now the current instruction is load a 100,000. Then IR register will send it to the internal address bus and will try to fetch the data inside 100,000 memory location. So it will send it via the MAR memory address register and the external address bus, and memory in the main memory it will fetch the data inside the memory location 100,000, that is 5. Memory buffer register will get the content, the 5, and then it has to be sent to A. It has to be loaded to A. So MBR will connect with the ACC via the internal database and it will store value 5 inside ACC. So this is the execution cycle. IR will fetch the value in the memory location via sending the address via MAR to the external address bus, and the main memory will read it. Then via the external data bus it will arrive at MBR. MBR will give it to bus D, and bus D will go and store in the relevant register, that is here ACC. Instead of A, if we had R1, it will store the data in R1 register. So this is the execution cycle of the micro instruction. In this video we learned about micro operations, the fetch and execution cycle, and how the micro operations are executed. In the next video we will discuss about control signals of the control unit which are generated when these micro operations are executed. Subscribe with Bloom and watch our next lessons.